All right, so today we are going to focus on finding polynomial equations given complex roots. So our learning targets are to write the quadratic equation given its complex roots or zeros, and find the complex and real zeros of a polynomial given a complex root and its equation. So let's recall the conjugate zero theorem. So it says that if a polynomial has real coefficients and if the complex number 0 is a 0 of p, then its complex conjugate is also a 0 of p. So when you have a plus bi being a 0, then a minus bi is a 0. So the example down there, given that 3 minus I is a 0, then you also know that 3 plus I is another 0. So our another one would be, for example, if 5i is 0, then negative 5i is a 0. If 2 plus I is a 0, then 2 minus I is a 0. To find the quadratic equation when given a plus bi and a minus bi, we can either do x squared minus the sum of the roots times x plus the product of the roots. And remember, sum of the roots would be that you would add together a plus bi and a minus bi, and then that would be the sum of the roots. And then the product would be that you take a plus bi times a minus bi, and that would be what would go in that spot. Another way to do this is you can always, given that the zeros are a plus bi and a minus bi, you can do x minus each one of those zeros. And you already know how to do that. So for instance, if you were given x equals 2, then you know that if that's the 0, and the other 0 there is x equals a negative 4, you would write this out as x minus 2 and x minus a negative 4. And then we could just go ahead and fold that out and get the answer. So in this case, if there were i's in there, then you would have its conjugate. But these are just regular real numbers, so that doesn't necessarily apply. But that's how you write it out. So our example there, it says find a quadratic equation, so that's a degree of 2. And it's told that we have 2 roots, and that'd be the only 2 roots because it's a degree of 2. So it's up to you how you want to do this. So you can do p of x equals x minus each one of those. And then I would distribute my minus signs through. So then here we end up with x minus 2 minus 3i, x minus 2 plus 3i because you have a minus a minus. So then we can just continue to multiply this. So you just distribute the x through the second set of parentheses. So we'd get x squared minus 2x plus 3ix. Then we take 2 and multiply by that second set of parentheses. And we get a plus 4. Minus 2x. And a minus 2 times a minus 2 is a plus 4. A minus 2 times a plus 3i is a minus 6i. And then our last one here, we take a negative 3i and distribute that through. So negative 3i times x is a minus 3ix. Negative 3i times a minus 2 is a plus 6i. And a negative 3i times a plus 3i is a minus 9i squared. So now we can combine our like terms. So a minus 2x and a minus 2x there is a minus 4x. And hopefully you see there's a plus 3ix and a minus 3ix. Those cancel out. And then we have a minus 6i and a plus 6i, and those cancel out. And then I'm seeing I've got a plus 4. And we know that the value there of I squared there is equal to negative 1. So I'm going to put a little negative 1 in there. So really we have minus a minus there is going to give us a plus 9. There is our quadratic there simplified down. P of x equals x squared minus 4x plus 13. That's one way of doing it. You take x minus each one of the I values. All right, so this one here says to find the other zeros here. So 1 0 there is a negative 2i. So it says it's a polynomial there, so we're going to assume it has real coefficients there unless it tells us otherwise. And so then the other one there is going to be a 2i. So let's go ahead now and figure out what the quadratic would be with that. So to write that out, it's going to be so you've got a minus there becomes a plus. Go ahead and fold that out. The middle terms there cancel out. Don't forget that I squared has a value of a negative 1. So you're going to end up with a minus there is going to become a plus 4. So let's come over here and let's use our long division here because we need to figure out another quadratic so we can find the other zeros. So remember how this goes. 2x to the 4th, there's a term missing in there, so 0x to the 3rd plus 3x squared, and there's another term missing. And then over here I missed one of them. So x squared plus 0x plus 4. So basically, this is coming out here. So now you have to think x squared times what is going to give us a 2x to the 4th there, and that's going to give us a 2x squared. So go ahead and take that 2x squared and distribute it through that trinomial there. Change your signs and add them together. Bring down your other terms there. So we can say think 5x or x squared times what gives us a negative 5x squared there, and that'd be a minus 5. Distribute that through this trinomial over here. Change your signs and add them together. So 2x squared minus 5 is the other, we're going to have the other two zeros there. So if I write it out now with its factors here, we know it to be x squared plus 4, and we know it to be 2x squared minus 5. So we already know what this x plus 4 ones here are. We know that's x equals plus or minus 2i. And then we have to set the other terms over here equal to 0. I'm going to add 5 to both sides. Divide by 2. Take the square root of both sides. We cannot leave a square root of in the denominator down there, so we're going to multiply the numerator and denominator by the square root of 2. The square root of 2 times the square root of 2 is the square root of 4, which is 2. So we get plus or minus the square root of 10 over 2. So our zeros are those. So one of our zeros here is 1 plus I. So let's go ahead and let's find our other 0 there. So to find it, remember it's the conjugate here. So if one's 1 plus I, then the other is 1 minus I. So let's go ahead and find the quadratic that makes. So we're going to do x minus each one of those. So distribute your minus sign through. And now we're going to have to go ahead and fold that out. Or I should say use the distributive property there 3 times. So if I distribute the x through, I get x squared minus x plus ix. Now I'm going to distribute my negative 1 through. So then I get a minus x plus 1 minus I. Now I'm going to distribute my minus I through. So then I get a minus ix plus I minus I squared. So now look to see if anything crosses out. And then don't forget that that I squared over there has a value of a negative 1. So really we end up there with so a minus a negative 1 becomes a plus 1. So we end up there with x squared minus 2x plus 2. So That's the quadratic that 1 plus I and 1 minus I there form. And that would be, if you use your quadratic formula on that, you would find out your two zeros there are 1 plus I and 1 minus I. We need to find the other two because it's an x to the fourth. So let's go ahead and let's use our synthetic division to find that. So I can think x to the second times what is x to the fourth? It'd be x squared. Distribute that through, so you get x to the fourth minus 2x to the third plus 2x squared. Change your signs and add them. So x to the fourths are gone. Bring down your next terms there. Now I have to think x squared times what is going to give me this negative 3x to the third. That would be a minus 3x. Distribute that through. Change your signs and add them together. All right, so then our next thing here, oops, I see what I did. This is supposed to be a plus, change the sign. That should be a plus of 20x. There we go. And then my last thing here, I have to think x squared times what is going to give me a negative 10x squared. It'd be a minus 10. Distribute through the trinomial there. Change your signs and add them together. And we get a remainder of 0 because those are two zeros. So we have x squared minus 3x minus 10. Whoops. Plus 2. So we've already found the zeros for this one here. That's your x equals 1. X equals 1 plus I. And x equals 1 minus I. So then we can factor this other one over here. What multiplies to give you 10 and adds to give you a negative 3 there. Multiplies to give us a negative 10 and adds to give us a negative 3. It'd be a minus 5 and a plus 2. So then how do you get 0 and how do you get 0 when x is 5 and when x is negative 2? All right, so then let's list out our zeros. I'm noticing that those numbers, 5 and negative 2 there, came out really nice integers there. So what we could have done up there, instead of doing all this, another thing we could have done is some people always take this x to the fourth minus 5x to the third minus 2x squared plus 14x minus 20, put that into the calculator, into the graphing calculator, and see if you get any nice integers as your solutions there, because if you do, then those are your solutions. So we could have graphed that out and saw that was 5 and negative 2 as well. It's just another way of doing that. So example 4 here. So this one here, I might go ahead and factor this. I've got an even number of terms. I'm going to pull out my x squared. I'm left with 3x minus 1. The second set over there, I'm going to pull out a minus 12. I'm left with 3x minus 1. What do those two terms have in common? They have a 3x minus 1. What's left over in front? X squared minus 12. So then we already found the 0 for the first set there. It's 1/3. The second set over there, we would set equal to 0 and solve. A square root of 12 can be broken down as a square root of 4 and a square root of 3. The square root of 4 there is simply 2, so we're left with plus or minus 2 square root of 3. So let's list our zeros here. One-third plus or minus 2 square root of 3. So this one here, example 5 here, you could pause the video if you want to, and then see if you can do this one yourself, and then check your answers. So 1, 0 here is 2 minus I, so the other one there is 2 plus I. We could try to graph this out on our graphing calculator, but you're not going to find any more on there, so we're going to have to do it this way. So let's go ahead and do x minus each one of those zeros to find the quadratic that forms those. I'm going to distribute my minus sign through. I'm going to distribute my minus sign through. Now I'm going to go ahead and multiply this. So I'm going to use the distributive property there 3 times. There's 1 time. I'm going to distribute the x through. Now I'm going to distribute the minus 2 through the second set of parentheses. And then I'm going to distribute the positive I through the second set of parentheses. All right, look to see what you can cross out. Notice you can cross out the minus ix and the plus ix. And you can cross out the 2i and the minus 2i. Combine your like terms. So I'm seeing I've got a minus 2x and a minus 2x gives me a minus 4x. And then that minus x squared over there can be replaced with a negative 1, so it's going to become a plus 1. So we end up there with an x squared minus 4x plus 5. So that's the quadratic that forms, and so we're going to have to now use long division there and divide that out to find the other quadratic so that we can find the other 2 zeros. So let's do that. So x squared goes x squared times what is x to the fourth there? It'd be x squared. So now take x squared and distribute it through that trinomial there, so we get x to the fourth minus 4x squared minus 4x to the third, and then plus 5x squared. Change your signs and add them together. Your x fourths are gone, and now we get 5x to the third minus 7x squared. Bring down the other two terms. Now we want to think x squared times what is 5x to the third? That would be a 5x. Distribute that through the trinomial there, so you get 5x to the third and so now we have to change our signs there and add them together. So the 5x to the thirds are gone. We end up there with 13x squared minus 52x, and then plus 65. So now we want to think x squared times what is a 13x squared, and that would be a 13. So distribute that through, so we get a 13x squared minus a 52x and plus 65. Change our signs and add them together. Notice what happens, everything crosses out. So we get a remainder there of 0, which is exactly what we needed to get. If you got some other remainder, you did something wrong. So now we're left here with p of x is equal to x squared minus 4x plus 5, which we found when we multiplied 2 plus I times 2 minus I. And then we just found the other part of the quadratic here of x squared plus 5x plus 13. So we already know the first two zeros here. And let's find the other two zeros over here. So that's not going to factor. If I look there, what multiplies to give me 13 and adds to give me 5, that's not possible. So we're going to have to use a quadratic formula on that one. So x equal, or opposite of b, so that's negative 5 plus or minus the square root of b squared minus 4ac. All over 2 times a. So we get 25 and so this ends up being 25 minus a 52 all over 2. So square root of negative 27, break that down. What times what gives you negative 27? Oh yeah, negative 1, a 9, and a 3. So square root of negative 1 there is I, square root of 9 there is 3, so I have a 3i. And so if you look on the numbers there on the outside, can you reduce them down? Do they have anything in common, all three of them? No, they do not. So because they don't have anything in common there, we're going to leave our answer like that. We can also pull it apart. I can put 2 under, I can divide -5 there by 2, and then I can divide the 3i squared of 3 over 2. So either way, you can write it either way, it doesn't matter. So our zeros there we have them. So I can write the quadratic equation given its complex roots or zeros. I can find the complex and real zeros of a polynomial given a complex root and its equation.